Hello. In our last video, we worked with trigonometry and used trigonometric ratios to solve for missing sides of a triangle. And we were using our calculators to compute those trig ratios for us. Today, we're going to work with our special right triangles from geometry class. And we will do these problems without a calculator. I hope you'll remember that in geometry class, you learned about two special kinds of right triangles. The first one was a 45-45-90, which looks something like this, where these other two angles were 45 degrees. And we learned about the relationship of the legs to the hypotenuse. If these legs were each 1 unit long, then the hypotenuse was the square root of 2. And in general, in a 45-45 right triangle, the relationship is if the sides are x, remember those are both equal or congruent. If the sides are x, then you just take those sides and multiply that x by the square root of 2 to get the hypotenuse. If you're working backwards from the hypotenuse, you would divide by the square root of 2. You also learned about the 30-60-90 right triangles, which looks something like this, where this is a 60-degree angle, this is a 30-degree angle. And we learned that if this is a 1, this is a 1/2, and this is a square root of 3 over 2. In general, this was our 60, this is our 30. If we know the hypotenuse, and we'll call that h, then this is h over 2, and this is h over 2 times the square root of 3, or h squared root of 3 over 2. So those are the relationships, and what we're going to do is assign trig ratios to these triangles. Now I've got that all compiled into a table here, so we'll show that on the next slide, and then we'll use that table and those trig values from the special right triangles to solve for some missing sides, similar to what we did in our last lesson. So as you can see here, we have the information all organized in a nice fancy table, not a triangle. It's organized in a table. And the trig values for sine, cosine, and tangent are all listed here. So everything in this top row is associated with this 30-60-90 triangle. And essentially what we do is just get the SOHCAHTOA off of the triangle, and then we write out what the fractions look like. Now, each of these fractions are famous. These are famous trig ratios. So typically what we would have you do is memorize those. You'd memorize that the sine of 30 degrees is 1/2, that the sine of 60 degrees is the square root of 3 over 2, and so on. While you're working on this first lesson, I recommend that you keep the table handy. Here in the second row, you can see these are the trig ratios for that 45-45-90 right triangle. There are fewer numbers to remember for a 45-45-90 because everything's repeated. So the sine of 45 degrees, doesn't matter which 45-degree angle you're looking at, is going to be the square root of 2 over 2. The cosine is also square root of 2 over 2. And the tangent is just the opposite over adjacent, which is 1. So these 9 values are the ones that we're going to use to solve these triangles. And like I said, for now, keep the table handy so that you have access to it. But eventually, you'll want to try and memorize these. It'll save you time having to look these values up. The key here is that we're not going to use our calculator to crank out these values. Like last week, if we needed the sine of 72 degrees, we typed sine on our calculator, put in 72, and hit equals, and it gave us back the decimal ratio. Today, we're going to use these exact fraction ratios for these 9 values. All right, let's check out a few problems, and then we'll get you started. So as you can see, I have a right triangle here. And although it's not explicitly written out, this is a 30-60-90 right triangle because this missing angle here is just 30 degrees, right? These have to add up to 180. We are trying to find the leg X length. They've given us the 60-degree angle, so I'm going to go ahead and focus on that angle. And then what I want to figure out is what are the names of the legs and the hypotenuse and where are they located. So we know that the hypotenuse is across from that 90-degree angle, so 100 is the hypotenuse. We know that the side across from our 60-degree angle here is the opposite side, and we know this side is adjacent. Now notice there's nothing labeled on this adjacent side, so we're going to avoid using the adjacent side. We want to use the information that they've given us. So they gave us that the opposite side was X, that's the thing we're trying to find, and we know that the hypotenuse is 100. So just like those problems that we did with our calculator, we're going to write out the relationship that we've been given in this triangle. We've been given the opposite over hypotenuse relationship, which is the sine of 60 degrees. And we know that that's going to equal the x, which is the opposite over the hypotenuse, which is 100. And then just like those problems that we did with our calculator, we need to transform this trigonometry into a number so we can do some math with it. Instead of typing sine 60 degrees on our calculator, though, we're going to go over to our little chart and we're going to locate that sine of 60 degrees and write that down. So the sine of 60 degrees is the square root of 3 over 2, and we'll use that to solve this equation. To solve this equation, we simply have to multiply both sides by 100. And that works out to be 50 square root of 3. Right? Because when you multiply 100 by the fraction square root of 3 over 2, the 100 and the 2 reduce to 50. And then you just write those next to each other, 50 square root of 3. We are going to leave our answers like this in radical form. So don't freak out if it's not the usual decimal number that you're used to writing down for your answer. This is going to be a number written in radical form. If you really want to know what the decimal value is, you can type that in on your calculator. But we don't want the decimal answers. For this particular assignment, we don't want to use our calculator at all. We want to use the radical form. So 50 square root of 3 on this one. All right, let's take a look at another one on the next slide. As you can see here, this is also a special right triangle. This is one of those 45, 45, 90 right triangles. We are given this 45-degree angle. That means that this side is the opposite side. And this is the hypotenuse. Those are the two sides that are labeled. So once again, we'll write out our equation using that given information. So we have opposite over hypotenuse, which is sine. So we write down sine of 45 degrees equals the x, which is the opposite side, over the 20, which is the hypotenuse. And then, just as we did in the last example, we have to convert this trigonometry into a number so that we can do the math. Sine of 45 degrees, that's over here. And that is the square root of 2 over 2. So rather than writing sine 45 degrees, we're going to replace that with the ratio square root of 2 over 2. And then we can finish off solving this equation. To solve this equation, we're simply going to multiply by 20 on both sides. And let's see, this 20 is going to cancel with that 2. That makes this 10 square root of 2, and we are done. The length of that leg is 10 times the square root of 2. So I happen to know the square root of 2 is about, 1.414, so that's going to be about 14. But we don't care. We don't want the decimal number. We are looking for this radical form. And so that's 10 square root of 2 units for that length. Now, not all of the problems end up with a sine function. So let's keep going and see if we can get some other examples with other trig functions. In this triangle, there are two missing sides that we're asked to find. We're trying to find x and y. And even though it's not indicated, we know this is a 60-degree angle. The angle that we're given is this 30-degree angle, so we'll work with that one. From here, we know that this is the adjacent side, right? This is the opposite side. And then, of course, this is the hypotenuse because it's across from that right angle. So we need to solve for x and for y. Let's just go in alphabetical order, and we will try and solve for x first. So the relationship that we're given here is adjacent and then hypotenuse. We want to use that number. We don't want to involve x and y in the same equation. Adjacent over hypotenuse is cosine. So if I write down cosine of 30 degrees, that's going to equal our x, which is the adjacent side, over this weird hypotenuse number. Don't freak out that that's a fraction. We'll deal with that in a minute. For now, we'll just write it down. This is what we call one of those complex fractions. Don't worry about it. It'll be all right. Okay, so cosine of 30, that's trigonometry. We want to convert that to a number off of our chart. Cosine of 30 is right here. And you'll see that that turns into the square root of 3 over 2. And that equals our complex fraction. Now we're going to solve this equation the same way we did those other equations. We're going to multiply both sides by this denominator here. That's why I wasn't really worried about it, because I'm going to solve the equation by multiplying both sides by that denominator. Okay. All right, so you know these cancel. Let's see if we can clean this up a little bit. This 4 is going to cancel with this 2. And remember how we multiply radicals. We multiply the stuff inside. So that's going to be, in the unsimplified form, this turns into a 2. This is going to be 2 square root of 9, square root of 18, over 3. Okay? And that equals x. Now, we're not going to leave that thing this way because 18 can be simplified. The square root of 18 can be simplified. Remember that the way we simplify radicals is we break them up into two parts. I call those the can do and the can't do. So the perfect square factor, which is 9, we're going to break apart from the 2, which is not a perfect square. Notice 2 times 9 is 18. And then I know how to do the square root of 9, so that turns into a 3. And so this is actually 3 square root of 2. So this fraction is 2 times 3 square root of 2, which I just figured out, over 3. And these 3's cancel. And so the answer for x, if you follow my arrow here, is 2 square root of 2. So we use the trigonometry to get to 2 square root of 18 over 3. If you made it that far, you did a great job with this new math. And then we're challenging you with these radical forms to remember how to simplify. And so that's a little extra challenge there for these problems. If you can simplify this thing down to its simplified radical form and write your answer that way. But if you made it here, if you made it to this step right here, you've done the trig. But we are shooting for this step. Now, we still haven't solved for y, so let's not forget about y. Y is the opposite over hypotenuse, or you could do opposite over adjacent, because now you know this is 2 square root of 2. So actually, I'm going to use the 2 square root of 2 just because that looks a little easier to work with than this weird fraction. So opposite over adjacent is tangent. So I write a separate equation. I'm going to squeeze it in down here. Tangent of 30 degrees equals opposite, which is y, over adjacent, which is 2 square root of 2. We go to the chart to find tangent of 30 degrees, which is right here. And that is square root of 3 over 3. So we convert this to square root of 3 over 3. And that's y over 2 square root of 2. We solve just like we did all the other problems. We're going to multiply both sides by 2 square root of 2. And, this one we don't even need to worry about simplifying the radical form, because 2 times 3 is 6. The square root of 6 doesn't simplify. So this just turns into 2 square root of 6 over 3. Right? I just multiplied these guys together. You multiply the numerators. Remember, this thing's over 1, even though it's not written there. So it's just 2 square root of 6 over 3. And that is the answer in radical form for y. So we found both missing variables. That is not a very neat highlighting job. So x was 2 square root of 2, and y is 2 square root of 6 over 3. Now, as I step back and look at this slide, it looks pretty messy. I hope you could follow it. Let's try one more and see if I can make less of a mess. Okay, this is our last example. Let's see what they've given us. This is a 45, 45, 90 right triangle, so it is a special triangle. We have to find leg B and hypotenuse A, right? We're given this 45-degree angle. This is our opposite side. This is our adjacent side. Excuse me, don't even listen to me. Let's rewind this. This is our adjacent side. And this is the hypotenuse. The hypotenuse is always across from the 90-degree angle. I don't know why I called that adjacent. That's just a mistake. Now, remember, just because we're learning some new math in trigonometry and algebra 2, you can still use your geometry to help you solve these problems. So take a look at this triangle. This is a 45, 45, 90. These sides are congruent. So if this leg is 2 square root of 2, B has to be 2 square root of 2. Why bother doing trig to figure out something that we already know? We do not mind if you are efficient and use prior knowledge to solve this problem. So I'm done with letter B. It is 2 square root of 2. To get the hypotenuse, though, I'm going to do a little trig. So let's use, why don't we use the opposite over hypotenuse? We'll go back to our famous sine function that we had in our first couple examples. So if I write the sine ratio out, the sine of 45 degrees is opposite, which is 2 square root of 2, over adjacent, which is A. And notice, to solve this, we're going to have to do a little extra math. So I want to solve for A, and right now A is in the wrong position. So here's a little trick. We can flip this fraction over, but in order to do that, we have to flip this thing over too, meaning that we have to do the reciprocal of whatever the sine of 45 degrees is. But this equation is easier to solve when A is in the numerator. So we'll just be careful when we go grab the sine of 45 degrees, we will write down the reciprocal, right? This means the reciprocal of the sine of 45 degrees. So here's the sine of 45 degrees. It's square root of 2 over 2. That means we're going to write down 2 over the square root of 2 because we need to write it as a reciprocal. And then to solve this thing, we're going to do the same old math that we've always done on these other examples. We're going to multiply both sides by this denominator. 2 square root of 2, 2 square root of 2. And these square root of 2's just cancel. And this is just 2 times 2, so this is just 4. So A, the hypotenuse, has a measure of 4 units, and we are done. So we used a little prior knowledge to solve for B because we know that the legs of a 45, 45, 90 right triangle are congruent. That's how we got the 2 square root of 2. And then we used trigonometry, and we used a little trick here with reciprocals to solve for A. Okay, hopefully this video is going to help you crank out the problems that you've been assigned. Let us know if you have any issues or have any questions. Good luck.